Hi everyone, we are back and let's go ahead and start with our contour plots today in Mathematica. So one of the ways is we can plot different functions, and contour plot is really cool because it's a function that will allow us to look at like a 2D projection of a 3D plot. So for example, let's look at cosine of x plus cosine of y. Let's go from minus x goes from minus 8 pi to 8 pi, and let's go from y goes from minus 8 pi to 8 pi. So we'll do plot. Let's see. Ooh, look at that pretty like lattice-like function. And so we could do lots of cool things again. So I could do color function. Let's do temperature because I like to. We're engineers, so I like that. We could do plot legends, automatic. So we can get a legend, a little scale here. So I could also do sine. And great. So again, you could just change those values and play around with it. So contour plot is a really cool function that you can look at and experiment with. You could also do contour plot 3D. So let's go ahead. We could do basically looking at this cosine of x, and then two functions here, cosine of y, and then try to do the same thing. Let's see, hopefully this will work. I haven't done the syntax for a while for this, so listen here. So again, always useful to just double check contour plot. Probably did something really stupid. 3D. So let's go ahead and look at that here. So we're looking at functions. So yeah, let's look at all the functions together, and we'll look at a z as well. So let's go ahead and look at, we need 3 arguments, cosine of x plus sine of y minus cosine of z, and then we'll put in z here as well, because I could do contour plot 3D. Let's do z, and let's see what we got. Waiting. Again, contour plot 3D is a little bit computationally expensive. And while that's doing, we could actually start to play around with list plot as well. So list contour plot, we can do something very similar. So I'm going to do table. I'm going to change the ranges here just to make sure that this is a little bit easier. So let's go from 0. Let's do 0. Let's do 0. Table. Let's go from basically I. I'm going to go from I from minus 10 to 10 in 0.1. And we could do x the same way. So let's do, or y, excuse me. Y as well. Let's wait for that. Those will evaluate soon. And then I could give a random z value as well to these x coordinates. So I want to do a list contour plot. Mathematica. Oop, see, finally got it. Woo, look at that. Isn't that a beautiful function? It actually looks a lot like block copolymer self-assembly or like a gyroid phase. But well, that was pretty. But again, that's why you save Mathematica constantly, because it could crash. So for my z coordinate, I'm going to just do a random real. I'm going to do from 0 to 0.5. And I'm going to go from all the way to the length of x, for example. So now I could just transpose my lists and then do a list contour plot. So transpose or list contour plot, and I could do, transpose, not transliterate, transpose x, y, and z. And I need to do, for example, I need to do data range all. And voila. So I could plot raw data as well. Density plots work very similarly. So I could go here, and let's go all the way down over here. So density plots, very similar, but I could just do density plot. And you could see these again. It's kind of like a mean field type approximation, so it's not as detailed as that contour plot. And then you could also do vector fields. We're going to get into this a lot once we start to look at basically diffusion mechanisms, kinetics, and basically fluxes. So this will be very useful a little bit later. So I'm going to do A and then minus x, or minus b, oops, And then let's go from a from -3 to 3, and let's go from y from -3 to 3. And then let's do plot legends, automatic. There we go. Ooh, why don't you? Ooh, that's why, because there's a y, not a b. Voila! Ooh! So again, you could see fluxes and all those kinds of types of things once we're working with. Actually, we could even flip it here, B and A, and you can see the little, almost like a spiral. So fluid flow, magnetic fields, all those things, they're very, very, very useful for that. So next time, we're going to get into manipulate and animate, which are really critical functions that you'll be working with, especially for your project. And yeah, then we'll do some insets, and then that's pretty much it. So, it actually should say dynamic, or manipulate and dynamic are very similar functions. So we're almost done with lecture 2. So I'll see you all next time. Thanks. Bye.